Hello everyone, welcome to the chapter Matrices. Here we discuss elementary row or column operations to find the inverse of a matrix. If A is any matrix and I is identity matrix, by the definition of identity matrix, it is written as A is equal to IA. That is the definition of identity matrix. Let's take an A matrix of 3 by 3 order and write it as the product of I matrix, the identity matrix, and A. Now, our intention is to find the inverse of this A matrix. The procedure goes this way. Do row operations on A matrix and same operations simultaneously on the same step repeat on the I matrix, keeping the post factor A intact. Now, we need to change this A matrix into an I matrix using row operations, various row operations. And same row operations are applied in every step on this I matrix to change it into some other matrix. Here, by the time this A matrix becomes I, this I matrix would become another matrix. Whatever this matrix is, this equation now reads as I matrix is equal to some matrix into A. And it is matching with the equation. I matrix is equal to A inverse into A. This is the definition of inverse of a matrix. A inverse into A is equal to I. Hence, we are then able to pick up the inverse of this A matrix as the matrix that we obtained during this operation. Now, in case we need to apply the column operations, we start with an equation A is equal to AI. Even this is part of the definition of the identity matrix. Notice that here A is equal to IA and here A is equal to AI. Let me write A matrix here and write the equation AI. I is the identity matrix. Here, do column operations on A matrix and the I matrix. By the time this A matrix changes into a column matrix, changes into an identity matrix using column operations, due to the same operations done on the identity matrix, it changes into some other matrix. Now this equation is now read as I is equal to A into some matrix, which matches with this equation A is equal to A inverse. So this matrix that we have obtained during this process can be treated as the inverse of the given A. And we pick up this and write it as A inverse. This is the procedure. Now during this procedure, these two procedures, many doubts arise. First of all, why are we applying the operations only on one of the factors? And that too on pre-factor in this method and on post-factor in this method. Here also one of the factors is kept intact, untouched. Why? To understand the reason behind this, let me take a new product. Product of two matrices I want to do. 3 by 3, 3 by 3. This is just an example to illustrate the reason behind this confusion. I want to multiply these two matrices. As we all know, the matrix multiplication is done by multiplying the rows of the first matrix with the column elements of the second matrix. Let me do 2a plus 1b plus 6c, 5a plus 3b plus 0c, etc. Matrix multiplication. First row is done. Then go for the second row. Then go for the third row. This is simply matrix multiplication. Now in this matrix equation, here, change the rows I'm going to interchange the rows in this prefactor and in this left hand side, the product. Interchange the rows. First and second rows have interchanged in both of them, keeping the post factor intact. Here what happened? After interchanging, look at the product. 2p, 1q, 6r. Yes, 2p plus q plus r, 6r. Every element is coming in the first row itself. So it is clear that even if we do not change the post factor, if we keep it intact and do the operation only on one of them, then exactly the product also gets the same effect. If you interchange these two rows on one of these matrices, that on the prefactor, the product also gets the same change. That's what this numerical example says. Hence, during this process, we keep I in the prefactor position and A as the post factor position to keep the A intact. So, rows of the product are affected by the operations on the rows of the prefactor. Now, in case the column operation is applied, what happens? Look, interchange the columns. I've interchanged the columns on the product as well as on the post factor, not on the prefactor. The reason is simple. The matrix multiplication is done with rows with column. Here, if you plan to apply the column operations on the right side, do the operation only on the post factor whose columns contribute in the product, not the rows. So, this matrix was unaffected. This is why in this method, column operation method, we keep the I as the post factor and keep A in the prefactor position. Reason, once more, column of the product are affected by column of the product. This column and this column are affected by the operations on the column of the post factor, and the prefactor is kept intact. Thank you.